How long would interstellar travel actually take? Have you ever wondered how long it would take to travel to another star? This question opens up a fascinating discussion about interstellar travel concepts and the future of human spaceflight. The nearest star system, Alpha Centauri, is about 4.37 light-years away. To put that into perspective, light itself takes over 4 years to reach Alpha Centauri. For spacecraft using current technology, the journey would take thousands to tens of thousands of years. Now, imagine if we could travel at a significant fraction of the speed of light. According to Einstein's theory of special relativity, if a spacecraft could reach 90% of the speed of light, a trip to a star 100 light-years away would take about 111 years from the perspective of people on Earth. However, the astronauts aboard the spacecraft would experience much less time passing due to a phenomenon called time dilation. This means they could age only a few decades during the journey, while centuries might pass on Earth. Time dilation is a fascinating aspect of physics. It allows astronauts to endure long journeys without aging as much as those on Earth. This effect occurs because time inside a moving spacecraft slows down relative to stationary observers. Therefore, while the crew travels, they can maintain their health and well-being over extended periods. To achieve these incredible speeds, spacecraft would need to accelerate continuously at about 1 Earth gravity. This would help create artificial gravity for the crew and ensure their health during the journey. However, reaching even a fraction of the speed of light requires immense amounts of fuel and advanced propulsion technologies that we have yet to develop. As astronauts train for space missions, understanding these timescales and the effects of relativity is vital. Training programs focus on preparing for the psychological and physical challenges of long-duration spaceflight. While current astronaut training does not simulate interstellar travel durations, the principles of endurance, life support, and mission planning are still relevant. In summary, interstellar travel to the closest stars would take decades to centuries from Earth's viewpoint. However, astronauts traveling near light speed would experience much shorter times due to time dilation. Preparing for such missions involves addressing the unique challenges of long-term spaceflight, including maintaining physical health, mental well-being, and operational readiness over extended periods.